All right. This is our last lesson for 30-2, so you guys should be happy. And this is tying perms and coms in with probability, and this is why we kind of left it now, because it all comes into play. We'll just wait because Lindsay came in late. All right. Like we said, we're going to tie this together, the probability and the permutations and all this kind of jazz. They're reminding you of all the formulas right here. This and this are on your formula sheet. I actually even believe so is this one. Permutations with repetitions. This thing isn't on there, but I told you whenever there's something the same, we have to divide it out. So that was one of our golden rules there that we talked about. So the rest of them should be on our formula sheet. Then we're just going to move to these class examples. First guy, it's not too tough. We've done stuff like this. 2 cards are selected. Right now, without replacement, that should tell you if it's independent or dependent. What is that? It's dependent because one's going to affect the outcome of the other. So we're taking 2 cards out, determine the probability that both cards are kings. So here, simple stuff we've done before. We want a king, and then we want a king. And we've done ands and ors forever, so by now we know that and simply means multiply. How many kings are in the deck? There's 4 out of a total of 52. Now the question says we don't replace it. So now we have 3 we could choose from out of 51 because 1's missing. Okay, so when we do this, will help us speed up the process. This should be 1 out of 221. You can check it with your math frac and all that kind of stuff. Now we're going to look at this. This is the multiplication law. We're going to look at it now using a combination because does it say anywhere that the order was important that the kings came out? Not at all. So we just need to choose 2 cards. So probability is always this fraction. Let's talk about the total first. How many cards do we have in a deck? 52. And this question is just saying I need to choose 2 cards. That's the total possibilities. 52, I need to choose any 2. But what are we actually talking about in this question? Kings. So how many kings are there? 4, and I need to choose 2 of them. And when we do this, you should crunch it out to see if you can get the same answer. It is the exact same thing. Okay, for those kings, choosing 2, divided by all the ways out of 52 cards, I can choose 2 cards. Okay. Next guy. In a card game, you're dealt 5 cards from the pack of 52. When you look at your 5 cards, what's the probability expressed in combination notation that you have 4 aces? Now, it is saying combination notation, so we're using that kind of stuff. We should remember that this could have been written like this up here, which I don't think in this example anybody would do this. That looks a little bit more confusing, but it could be written like that. That's another way to write combinations. So 4 aces, but we need a 5-card hand, right? So we're going to still say our total is 52 cards, and how many are we choosing? 5 of them. Okay, we need a 5-card hand, but we need 4 aces and, which means multiply, what? Something that's not an ace, right? So 4 aces, how do we get that? 4, choose 4. And we need a different card. How many are not aces in that deck? 48 of them. So we got 48, choose 1. Now it's not even asking for the answer, so we can leave it. That's good. That's combination notation. On your diploma, sometimes they just leave it like this. They're saying which one is the probability, and you have all these combination or permutation statements that we can get. Same thing here. I want 4 tens and then 1 ace. Still, the total, I have 52 cards. I'm just choosing a 5-card hand. But I need 4 tens. So how do I write that in combination notation? 4, choose 4. I want all of them. And now I want 1 ace. So 4 aces, and I just want 1 of them. And you can crunch that out. Just a word to the wise here. If you're actually crunching this out in your calculator, I would probably suggest do the top and then write down that answer. Do the bottom, then write down that answer. Try not to do everything all in one step because sometimes that's going to lead to some massive confusion. Now, in this next little part here, I want you guys to read these and I want you to try at least C all by your lonesome. Okay, and then we'll come right back to it. Ooh. Okay, we had some time to do it. Now we need a 10, a jack, a queen, a king, and an ace. It's not saying anything about order, but that is 5 cards. So we still know my total is 52, choose 5. Now if I want a 10, how do I get that? 4, choose 1. If I want a jack, how do I get that? 4, choose 1. And then a queen, 4, choose 1. And then a 4, choose 1, and a 4, choose 1. How many times am I doing 4, choose 1? I'm doing it 5 times. Now am I going to multiply this by 5? Or what is this thing? Maybe I should write it out. 5 times. Is this 5 times 4, choose 1? No, what is it? It's 4, choose 1 to the 5th power. Because I'm taking it and timesing it by itself 5 times. Nothing's wrong with this big long thing we wrote here, but people would probably write it this way. All over 52, choose 5. And we're laughing. It should not give you a negative at all. So we'll have to look. It can't because 4, choose 1. 4, choose 1 to the power of 5. No. Let's take a look. Bust those calculators. All right, when we're looking at our calculator, put that in. Make sure this thing is in brackets. If you don't put it in brackets in your calculator actually writes it funny, right? It does this, NCR1. And if you just put the 4 here, it says 4, choose 1 to the power of 4, which is still 1. So that's not enough. Okay, last one. At least one jack. These are the ones that we said at the end. At least, at most. These questions mean there's a little bit more thinking involved. Now, at least one jack. We can do this the long way. What's the one thing we don't want to happen? If we need at least one jack. We don't want the situation where there's no jacks. So all the probabilities are 1 or 100%. And I want to subtract the possibility that we get no jacks. So there's 1. No jacks out of a 52 choose 5 card hand. How many cards are not jacks? 48. And if I don't want any of them, so I'm going to say 48, and I just want to choose 5 of those. Whatever this number is would be the same thing as having at least one jack, because we're getting rid of that whole probability. Gander. All right, the word counted has been spelled in Scrabble tiles, because that's how bored we are. And Kayla just walked in. Hello, Kayla. 2 tiles are randomly chosen at one time and placed in the order in which they're chosen. So right here, this is saying order is important. So we're talking of a permutation. So we either use a permutation or we can use the fundamental counting principle. Determine the probability that these tiles come out and they say CO. So it has to be in that order. Okay, order is important. There's only one way that these can come out being CO. You pick the first one, it's a C. You pick the second one, it's an O. So there's one way. What's the total number of ways that I can actually take 2 tiles out of the thing counted, out of the word counted? How many letters in counted? 7, and I'm taking 2, but it said order is important. So this is 7 permutate 2, which... Now crunch that in your calculator. What do you get? 1 out of 42. Thank you. Okay, so now, I guess one thing we should point out right at the beginning. Look at the word counted. Is anything repeated in there? If it was, what would we have to do? Divide out our repetitions at the end. So nothing's repeated. Now, both vowels. How many vowels are in counted? 3. And how many do I need? 2. Is the order important? Yeah, they say right here. Order is which they come out is important. So the top, I'd say I have 3 vowels and I want to pick just 2 of them. Out of a total of 7, and I'm taking 2 of them. What's that probability? So it's 1 over 7 in the end. Before, I think it's 6 out of 42. Doesn't matter if you jump right to there. But 1 out of 7 is the answer you'll see. You'll never see it not in reduced form. Okay? So now we're talking about probability with perms and coms. So let's take it a little bit further here. And everybody has an MP3 player, which Nowadays, I don't know if we call them MP3 players. We just call them your phone or your music player. Yeah. Mike's MP3 player contains 50 songs. If he listens to 10 songs on random, determine the probability. Then it says as a percentage. No big deal. If you can find the probability, you can convert to percent. To the nearest hundredth that the playlist contains Mike's 2 favorite songs. Now, does it say anything about that the songs come first or last or anything? Not a chance. So this is a combination. So we're going to talk about the bottom of this thing first. How many songs are on his iPod? 50, and he wants to listen to how many of them? So 50 choose 10 is the bottom of this thing. Because we got 50 songs, we're going to choose 10 in any order. Now it does say we need his 2 favorite songs. So how many songs are his favorite in there? 2, and I need? There's 2 of his favorite, and I want to take both of them. So his favorite songs are 2, choose 2. Now, does it matter what the other songs are? No, so now I need to choose how many more songs? 8, and how many do I have to choose from? 48. So I have 48 songs left, and I need to choose 8 of them, because this 8 and this 2 make up the 10 songs. So now you should take the time to crunch this out. They do say as a percentage to the nearest hundredth, which is 2 decimal places. All right, so Mackenzie, crunch this out. You got 0.03673-ish, right? This is just a decimal. To a percent is 3.67% chance that if it's just on random, his 2 songs will come out. Now, it does say to 2 decimal places, so if this was numeric response, which basically this question would lend itself to, you should have 2 decimal places rounded well. Okay, the second part is one of his 2 favorite songs at the beginning of the 10 songs, and the other ones at the end. What does that tell you about the order of these songs now? It matters. So now this is a permutation. So on the bottom, we have 50 songs. We're going to permutate 10 of them because the order is important. His 2 favorite songs, is the order where they go important? Yeah, so we say his 2 favorite songs. Now we're putting them in a specific order. 2 permutate 2. What's left over for songs? 48 permutate 2, because the order is important. They're coming. Oh, sorry, 8. Yeah, my bad. So this should be an 8. We'll fix that. Isn't that a lovely 8? Now it's still saying to 2 decimal places for a percent. Did you get this, Mackenzie? Oh, wait. It doesn't matter. You're getting e to the negative whatever, right? How do you find percent? You always times by 100. What's that times by 100? So 0.08%. So that's very slim that these songs will come out exactly how he wants it to go. Okay? Last example. City Council has 9 men, 6 women sitting on it. They need a 3-representative committee to be formed. So committee or subcommittee. There's no order important here because committees don't have, so this is a combination. But it says that Mayor Jim, whatever, Milanovich, has to be on the committee. Now, assuming that Jim is a male, okay, this makes a difference in our question. How many people are actually in this pool to choose from? 15. And I need to choose 3 of them for the subcommittee, and it's up there somewhere. Oh, Jim and 2 women. So Jim is one guy. How do I choose Jim out of this? Nope. Choose one. Because I got to take that one guy and choose one. So that's kind of redundant, but choose one for Jim. He has to be on it. Now, how many women do I have to choose from? 6, and I need to take 2 of them because I only need 2 more women on this to 3-person committee. What is this in lowest terms? Say that again. 3/91. Make sure you can get those numbers. Let's go here. So this last one is a little different. It's kind of worded weird. but we'll talk about it. Now, Jim has to be on the committee. So we're not even looking at him as part of this original chunk of people. So our total, if he's already on it, how many people are we choosing from? 14, and I need to choose 2 because Jim is already there. We're not even considering him. Jim's already there. Now, Jim must be on the committee, and the rest are women. So how many women do we have to choose from? 6 choose. 2. What's that probability? 15 over 91. Nope, because it's saying he's on and just 2 women. And it's still the 3-person committee, so we don't have to even think of the men. The 14, Sky's asking, where did this 14 come from? Because we had the 9 and the 6 women at the beginning, but Jim's now out of the pool. We're saying it's not even a choice. This one's kind of saying, well, it's kind of if he's on there, what's the probability he gets on? There's still cases where he's not. This one's saying he has to be on, so now the probability is a little different. So that is probability with perms and comps. Lovely, lovely.